This is number 42, doesn't look like it, 42 in chapter 8. Another good review problem. In this one, we have another carnival ride. In this carnival ride, the people ride in these rockets, they call them, that are hanging by chains to a disc that spins. Okay? And so the whole disc spins, and you notice while it's spinning that the cars swing out to a 20-degree angle from vertical here, while it's spinning at full speed. We know the length of the chain is 6 meters. We know that the radius, the diameter was 5 meters, so the radius of this is 2.5 meters. What we want to do is figure out what is the car's speed as it's going around here. So, we start all of them the same way. We're going to do a free body diagram. So a free body diagram, we have tension going this way, we have gravity going this way. Okay? And then, I'm going to draw my coordinates, but which way do I want my coordinates? I know some people, I always get confused in this, but I got to think about which way is the car moving. Well, it's moving in the x direction. That's the way it's moving. It's not going in the y direction. It's going in a circle in the x direction, or a horizontal circle. So I'm going to have my coordinates this way so that I have two axes, and this is the axis of motion, the x coordinate. And notice this is 20 degrees up here. So you can think of it this way. This is 20 up here, so this is my 20-degree angle right here. So then I take the components of the tension. This is T cosine 20 degrees. And on this side it's T sine of 20 degrees. Alright. Now we need to solve for the car speed. So what we're going to do is we're going to say, what's F net x? Well, F net x is just equal to T sine of 20 degrees. Okay. But T sine of 20 degrees has to be equal to the centripetal acceleration, because that's the way it's going in a circle. So this becomes mv squared over r is equal to T sine of 20 degrees. And we want to solve this for v, so we're going to get v is equal to T times m sine of 20 degrees over r. Okay, you're like, well, we don't know the mass, we don't know the tension. Okay, don't worry, keep going. We're going to go F net y. F net y, we got T cosine 20 going up minus mg going down. But in the y direction, we know it's not accelerating, so that becomes 0. We can say that mg is equal to T cosine 20, or I can solve this for t and say t is equal to mg over the cosine of 20 degrees. I can plug that back in for t. One second. Oh, sorry. I messed up here. This is where I messed up. You probably caught it, but weren't there to tell me. It should be T times R over M. So I'm going to put in mg over cosine 20 for t. So I'm going to go back to this one and plug this in for t. So let me do it over here. So v is going to be equal to mg over cosine of 20 degrees for t times r times the sine of 20 degrees over m. Well, the m's cancel out. Sine over cosine becomes tangent, so v is equal to gr tangent of 20 degrees. Now we just got to figure out what r is. Well, r, this is this r, but the radius, we're going to call big R, that's how big a circle it's making. So you have to go for the full circle, full center there. Just because it's connected out here doesn't matter. You got to do the full radius of the circle it's going to. So we got to figure out this, and then we add 2.5 to it. So to do this, we're just going to do a little trick. We know the hypotenuse, we know the angle. This is opposite, so it's got to be sine. So the sine of 20 is the opposite, which is r over 6, or r is equal to 6 sine 20. But big R is equal to 6 sine 20 plus 2.5. Okay? So down here I can plug all this in. This is 9.8 times the quantity, 6 sine 20 plus 2.5 times the tangent of 20. And you plug all that into your calculator. Grab my calculator, and you should get a value of boy, I'm making mistakes all over. You notice back here, this is still squared. I don't know why I didn't keep the squared. So this is v squared, v squared, v squared. So v squared is equal to 16.237. But v, I just have to take the square root of that. And I got 4.029 or 4.0 meters per second, which I believe is the correct answer. That is the correct answer. All right, that's how it's done. You got to be better than I am. Don't be sloppy. Don't lose your squares. Don't do simple algebra mistakes. But that's how it's done. Not bad. All right, that's it for that one.